Hi Jerry, this is Jim Gibson. We're in the cellar, and this is the geothermal unit that I've had hooked up for 2 winters, and we're using pump and dump now with it, which is really doing fine for the house. I'll show you what I did. This is an amateur's first shot at geothermal, so I don't know whether I'm over-engineered or under-engineered, but I'll go through and explain what we've done. The main loop, which will be the ground loop, I suppose, next, is down here on the bottom, and we bring the water in. We have the entry cutoff valve, and then the valves that restrict the flow are on the outflow side so that it doesn't develop spaces or air in there and all. I have actual gauges that are both pressure and temperature on both the incoming and the outgoing line there. We just bring water in from our pump. It comes in here, runs through a filter, strainer type thing there, and then this goes out and has dumped it into the yard with our restricting valves, and those are what I work with to back the water off, and it seems like 7.5 or 8 gallons a minute on this 5-ton unit has done a good job. At that rate, our water comes up consistently at 55 out of the well, and it pushes it down to we're sending water out in the yard at about 40. That's of course in the heating mode. I haven't even tried this thing yet in the cooling mode, and I haven't tried the super deheater yet. So that's the ground loop circuit, or the open circuit. For the heating circuit here, this is the pumping out, water going uphill here, and we have a 125 gallon tank used as a buffer tank. I think this tank was probably designed for solar hot water. It's maybe not configured exactly like it should be, but I come across from there. I have a valve where I can just control the flow through here. Then I go through and have a pressure tank on, and from there we have a T, and we can go into the tank with water at that point, or the water can continue on into the system, into the basically a manifold I made to heat with. Now, the other end of that loop comes out of the bottom of the tank down here, and it's connected in with return, a made-up return manifold from our heating system. I'll go over that in a little bit. And I come up, and in an effort to keep air out of this system, and only had a 3/4 inch air eliminator here, so I ran a 3/4 inch branch, and I throttle it back some with a valve, forcing about half of the water flow to go up over this loop, figuring that the air will go up anyway, and it seems to, I guess, keep the air out of there. And this is one of the, I guess, Grundfosses, or some name like that, the pump. And this is a 3-speed 230 volt, which I hooked right into the 230 lines in the Climate Master. So when we run it, my idea is to just heat up the water in the tank primarily, and we have a thermostat here that I can set on heating or cooling, and can change the settings all around on it. It has a probe into the tank about 1.5 feet from the top into a well, I guess it is, into the tank, and so that's where it gets its reading. And I've been setting it at about 125 on and about 100 degrees off on heating mode. So going from there, we come out and I have one loop here that goes into the, I guess you call it hydronic coil, into the furnace cold air return. And that's got another one of the same pumps, and it's 110, and it will run 3 speeds. And we're valved in and valved out, and we have temperature, so I can see what the temperature of the water is going to the coil and what it is coming back, and then it drops into my made-up return loop here. So this will be, this gives me the return temperature here. The coil that's in the furnace, I'll show you. I bought one for the air conditioning circuit in the attic, but I think they call it a 4-tube. And I had one that was thinner, didn't seem to transfer enough heat from water to air, so I just got one that was had more coils in it or more thickness for the water to transfer heat to air. This seems to work in there. That will have to be changed when we make it work with air conditioning also, so that I can fit a drip pan and all. So it's just an experiment lying in there now. The only issue I have with that is that it restricts the airflow enough that if you use the furnace in the regular configuration as a hot air, the furnace will kick off because it doesn't get enough air through it to keep the burner cool enough. Temporarily, if I just have to, in an emergency, I just crack the door to the filter down here and let a little extra air in just to make it work. And that does work. The blower I experimented with different speeds, thinking that I could run a lower speed, maybe with the solar, or not solar, geothermal water, but it is best at high speed, which is what it runs for the oil. So it seems like I'll just leave that running high speed all the time, the air moving motor in this furnace itself. And it's just set up to turn on the furnace with a separate thermostat, and the relay kicks on the pump at the same time. So it's just a little self-designed single system that way. Now the other thing, I did put a temperature valve right in the plenum chamber, and knowing that the temperature is maybe 62 to 65 coming off of the cold air return upstairs, I can see how much temperature rise that I get here on the air going through the furnace due to the heat exchanger. That's just to help me study how the system works. Now the other thing we do with this is we have two floors in the house which have heat in the floor. One is concrete and one is warm board on top of an older concrete slab we had, so we had to retrofit that one. So this third circuit, another one of these, it's a 110 but 3-speed pump, and it goes out and splits between one line, 3/4 line goes out to near the kitchen, and underneath the kitchen cabinet it splits there into the two circuits that do the floor. So it has a run before it gets there, and then a run back from there. The other half of the split comes up and goes in, and we actually have the manifold for our concrete floor, which is nearby, is here. So it has two circuits in it, and so they're both at this point. And we can control them with the valves to send more to one or more to the other one, or just kind of play with it however we want to. We have temperature valves coming and going on everything, so we can at least analyze what's going on. I guess, I don't know if I have any questions about that. We also have here, there's an internal coil in this tank that was independent of the water that's in the tank as it is, and so I just ran a line in and out of it. We had 25-year-old solar panels for hot water on the roof, and of course they work better in the summer than the winter, so I went ahead and just tapped the line from this buffer tank into my circulating system, so that I have a choice of turning off the water to the solar panels on the roof and just turning it on to the coils in that buffer tank. This is the buffer tank, or I guess it's a buffer tank or exchange tank, that has a coil in it. We use it to preheat our hot water, and then I run over to there to a regular hot water heater, so the last 20 degrees maybe sometimes is heated electrically, but most of it's heated by one of these other two units there. It has its own little pump here, so that's just an experiment we've run with that. And nothing here is insulated because I was going to get it all going before I did that, but I know it should be. The basement down here is, it stays 65 degrees or so. We've insulated all the perimeter joist-in spaces and everything that we can, and most of it's below ground. And there's no insulation between this and the floor upstairs anyway, so we're figuring on whatever heat we lose down here is just part of what's the residual heat in the house. The only problem that I've had with this is that it seems like sometimes with startup, and that's not startup each time, that's like if I start up at the beginning of the season, or more likely if the system, we hit a warm spell and it wasn't used very much, you know, for 2 or 3 days, like warm spell in the winter, and then it was going to kick back on normally and go, that it would stop. It would run its 90 seconds or whatever, and then it would flash light number 4, and it always does the same light, and it's an automatic cutoff of somehow in there to keep it from burning up the unit. And so, which it's doing its job. I think I'm getting some sort of an airlock maybe, and I'm just not moving water through it for some reason or another, and that's why it cuts itself down. And then I just turn this off and on, or change the speed of the motor, or I've even injected more water into it, and I'm using just softened water in this secondary loop, everything now. But and then it just